Good morning, children. I hope you are all doing well. Today, we are going to discuss IUPAC nomenclature related to carbon and its compounds in your state textbook. We have already discussed various things regarding this lesson: versatile nature of carbon, functional group, homologous series, allotropic forms of carbon we have discussed. Now we are going to discuss IUPAC nomenclature. You are very well familiar with the word IUPAC, which is International Union of Pure and Applied Chemistry. With the increasing number of organic compounds known, scientists felt the need of a specific system for naming of those compounds, and they have arranged a convention. In that convention, they have decided that any organic compound with a given structure should be represented by one and only one name throughout the world. In the same way, any compound with a known name should be represented by one and only one structure. Basing on this motto, they have proposed some rules for naming of organic compounds. As per that IUPAC convention, IUPAC name of a compound is made up of three parts. Let's discuss that now. First part is prefix, which is followed by root word and then suffix. Prefixes again having two parts. They are secondary prefix and primary prefix. Root word is not having any parts in it. And the same way, suffix is also having two parts, that is primary suffix and secondary suffix. In prefix, secondary prefix and primary prefix, in addition to them, it may be having number prefix and numerical prefix. And the same way, suffix, primary suffix, secondary suffix, they may be added with number suffix and numerical suffix. So you'll be getting it out. What do these indicate? So secondary prefix, it gives information, it gives the names of substituents present in an organic compound. Substituents like alkyl substituents, halogen substituent, nitro substituent, alkoxy substituents, their name is indicated in the form of secondary prefix in IUPAC name of a compound. Primary prefix distinguishes in between allopathic compounds and cyclic compounds. We all know allopathic compounds are compounds containing open, straight chain or branch chain of carbon atoms, whereas cyclic compounds are those containing closed ring of carbon atoms. So that primary prefix will be cyclo for cyclic compounds. For an allopathic compound, no primary prefix will be there. Root word gives information about number of carbon atoms in parent chain. Root word gives information about number of carbon atoms in parent chain. Suffix, primary suffix, it gives information about the nature of the carbon chain. That means whether the carbon chain is saturated or unsaturated. That means whether a carbon compound is containing all carbon-carbon single bonds, or is it having a carbon double bond carbon or carbon triple bond carbon. That information is provided by primary suffix. Finally, coming to secondary suffix, that gives the names of functional groups present in that compound. You know, a functional group is a group of atoms replacing hydrogen atom and dictates the properties of that compound irrespective of length and nature of carbon chain. So, what is functional group? A group of atoms replacing hydrogen atom in a hydrocarbon and dictates the properties of the compound irrespective of length and nature of the carbon chain. So, let's go in detail regarding this now. secondary prefix. Gives the names of substituents like alkyl group, which is having general formula CnH2n plus 1. You all know alkyl group is obtained by removal of a hydrogen atom from alkane. You know that alkanes are having general formula CnH2n plus 2. If one hydrogen atom is removed from that, it will be having the formula CnH2n plus 1. For example, if methane, CH4, methane, if one hydrogen atom is removed from that, I will be getting CH3, which is nothing but methyl group. In the same way, ethane, C2H6, one hydrogen atom is removed, I will be getting C2H5, which is ethyl group. Methyl group and ethyl group are different types of alkyl groups. Second substituent we are going to discuss is halo. That means halogen, which can be represented by X. Here, X can be chlorine, bromine, iodine. If X is chlorine, chloro. If X is bromine, bromo. If X is iodine, it will be iodo. Nitro group, NO2. Phenyl group, C6H5, which is obtained by removal of hydrogen atom from benzene. Alkoxy group, OR. You know that alkyl group is represented by R. That is added with oxygen atom, so which can be referred to as alkoxy group. These are the different types of substituents that can be present in an organic compound, whose name is indicated in secondary prefix. Next, coming to primary prefix. Primary prefix distinguishes allopathic compounds from cyclic compounds, and it will always be cyclo. No need of further writing it on the board. And coming to root word, gives information about number of carbon atoms in pairing chain. Number of carbon atoms in parent chain. If parent chain is containing 1 carbon, it is given root word meth. 2 carbons, it is given root word eth. 3 carbons, prop. 4 carbons, but. 5 carbons, pent. 6 carbons, hex. 7 carbons, sept. 8 carbons, oct. 9 carbons, non. 10 carbons, dec. If parent chain is containing 1 carbon atom, it is given root word meth. 2 carbons, eth, prop, but, pent, hex, sept, oct, non, dec. Next, coming to primary suffix. I said to you that primary suffix gives information about nature of carbon chain. Primary suffix informs nature of carbon chain. If carbon chain is saturated, primary suffix will be ane. If carbon chain is unsaturated with 1 C double bond C, it will be ene, E-N-E, ene. If it is containing two C double bond C's, it will be diene. Here di will be numerical suffix. Di will be numerical suffix. If it is containing three C double bond C's, it will be triene. Here again tri will be numerical suffix. If a carbon chain is unsaturated with one C triple bond C, it is given primary suffix YNE, ine. If it is containing two C triple bond C's, it will be diene. Here again di is numerical suffix. If it is containing three C triple bond C's, it will be given triene as the primary suffix. So once again, primary suffix informs the nature of carbon chain. If carbon chain is saturated, primary suffix will be ane. If carbon chain is unsaturated with one C double bond C, it will be ene. Two C double bond C's, diene. Three C double bond C's, triene. In the same way, it is unsaturated with one C triple bond C, it will be ine. Two C triple bond C's, diene. Three C triple bond C's, triene. Last part of IUPAC name of a compound is secondary suffix. Already I said to you, it gives information about functional group in the compound. You know, you are having different types of functional groups. Carboxylic acid, which is found formula COOH. It is given secondary suffix oic acid, OIC, oic acid. H2 functional group is represented by formula COOR. It is given suffix OH, alkyl alkanoate. If it is containing acid chloride with formula COCl, then secondary suffix will be oil chloride, oil chloride. In the same way, if I consider acidamide, CONH2, it is given suffix amide, AMIDE, amide. Nitrile, CN, it is given suffix nitrile. Aldehyde functional group CHO, it is given secondary suffix AL, al. Ketone CO, it is given suffix on, ONE. So once say this, secondary suffix gives information about functional group in the compound. Different types of functional groups. Carboxylic acid functional group COOH, it is given secondary suffix oic acid. Esters COOR, it's not ester, it's ester. It is given secondary suffix OH. Acid chloride COCl, it is given secondary suffix oil chloride. Acidamide CONH2, amide. Nitrile CN, nitrile. Aldehyde CHO, all. Ketone CO, on. Followed by alcohols, OH group is given secondary suffix OL. Amine group NH2 is given suffix amine. Alkene C double bond C, already you know, ene. Alkyne, C triple bond C is given suffix "-ine". Okay, these are the parts in the IUPAC name of a compound. Now let's discuss scheme of naming a compound as per IUPAC guidelines. So first step in IUPAC naming of a compound is selection of parent chain. Selection of parent chain, that is the most important step in the naming of a compound. So longest possible continuous chain of carbon atoms. Longest possible continuous chain of carbon atoms is to be selected as parent chain. That is the first step. The longest possible continuous chain of carbon atoms is to be selected as parent chain. Longest possible continuous means the chain that is containing more number of carbon atoms. So for example, if I consider a compound like this, CH3, CH2, CH3, CH2, CH3. If a compound is given like that, so first of all, first step is you should select the parent chain that is containing more number of carbon atoms. So 1, 2, 3, 4. That is a 4 carbon chain. We'll see for other chains too. 1, 2, 3, 4, 5. 5 carbon chain. 5 carbon chain is to be selected as parent chain there. You'll be getting it out. So then what about this methyl group? Any carbon atom or group of atoms which are not the part of parent chain are to be treated as substituents. Any atom or group of atoms which are not the part of parent chain are to be treated as substituent. That means here this group is not the part of parent chain. That's why it is treated as substituent. Another example we'll see. If you have a look at the compound, first of all, our mind tends us to go in straight. You should not go like that. So you should see the number of carbon atoms in each chain. 1, 2, 3, 4, 5, 6. That is one chain. 1, 2, 3, 4, 5, 6. Anyhow, it's same, 6 carbons. We'll see for another chains too. 1, 2, 3, 4, 5, 6, 7. 7 carbon chain. This is to be taken as parent chain. Then this will be substituent. So that is about selection of parent chain. Next step is numbering of carbon atoms in parent chain. After selection of the parent chain, you should number the carbon atoms that are present in parent chain starting from 1, 2, 3, 4 and so on. For numbering, 2 simple rules are there. First rule is while numbering of carbon atoms in parent chain, we should take care that carbon atom of the parent chain to which a substituent is attached must get the lowest possible number. Simple rule. A carbon atom kaithe substituent attach ayi untundo, that carbon must be getting lowest possible number. That number allotted to substituent bearing carbon atom is referred to as locant number in చెప్పంటాను. What do we call it? Locant number. అంటే substituent bearing carbon atom of the parent chain must be getting lowest locant number. That is rule 1 in numbering of carbon atoms. Second rule వచ్చేటప్పటికి, if in a compound 2 or more than 2 substituents are there, you should number the carbon atoms in parent chain in such a way that sum of the locants must be lowest. sum of the locants must be lowest. By following these two, we'll be numbering the carbon atoms in parent chain. So step 2, numbering of carbon atoms in parent chain. That first one is substituent bearing carbon atom of parent chain must get lowest possible number, must get the lowest locant number in the lowest locant number. If you see an example for that, CH3, CH, CH3, CH2, CH3, 4 carbon chain will be the parent chain, this one. So numbering can be done either from left to right or from right to left, but by numbering from right to left, 1, 2, 3, locant number will be coming 3. If it is from left to right, 1, 2, 3, 4, locant number will be getting 2. So correct mode of numbering is from left to right, 1, 2, 3, 4. That next point you have to observe is, if 2 or more substituents are there, if 2 or more substituents are there, then sum of locants must be lowest. This is referred to as lowest sum rule and చెప్పంటాను. For example, CH3, CH2, CH, CH3, CH2, CH, NO2, CH3. Of course, 1, 2, 3, 4, 5, 6, 6 carbon chain is to be taken as parent chain without any doubt. It's containing 2 substituents, nitro and methyl substituent. So numbering is to be done from right to left. Why? Because 1, 2, 3, 4, 5, 6. While numbering from right to left, sum of the locants is 2 plus 4, 6. If you number it from left to right, 1, 2, 3, 4, 5. 3 plus 5, 8. So 2 plus 4, 6. Lowest carbon, I will be numbering it from right to left. That is about the numbering of carbon atoms in parent chain. You will be getting it out. Sir, if in a compound a functional group is there, if in a compound a functional group is there, then how do you have to number? And cheppante, in the presence of functional group, while numbering carbon atoms in parent chain, you should remember one thing, that it is carbon atom of the parent chain bearing functional group should get the lowest locant number. If in case a functional group is present in a compound, carbon atom of the parent chain to which a functional group is attached must get the lowest locant number. Sir, what if substituents are present? Don't bother. If in case a functional group is present in a compound, what one should consider is functional group bearing carbon atom should get lowest locant number, irrespective of locant numbers of the substituents. If a functional group is present, then functional group bearing carbon atom should get the lowest locant number irrespective of locant numbers of irrespective of locant numbers of substituents. For example, if I consider CH3, CH2, CHOH, CH3, a compound is there like that. It's not having any substituent. 4 carbon atom chain is to be considered as parent chain, and numbering is done from right to left. 1, 2, 3, 4. So alcohol functional group carbon is getting locant number 2. So if in case CH3, CHNO2, CH2, CHNH2, CH3, a compound is there like that. Here you can see nitro group is substituent, it's not a functional group, and amine group is another functional group is present. So I said to you, while numbering, you should take care that functional group bearing carbon atom should get lowest locant number. So 1, 2, 3, 4, 5 it will be. Then we should look at another example. CH3, CHOH, CHNO2, CH3 is there like that. Then alcohol group is there. Nitro group. Nitro group is substituent, alcohol group is functional group. So I'll be numbering it from left to right. 1, 2, 3, 4. After this, you can write the IUPAC name of that compound. First, you should write secondary prefix. While writing secondary prefix, you should use number prefix or numerical prefix to indicate the locant number of substituent. And locant number and name of the substituent must be separated by hyphen. Locant number and name of the substituent must be separated by hyphen. If in case 2 or more than 2 substituents are there, name of the each substituent is to be separated by comma. Okay? Like this. CH3, CH2, CH2, CH, CH3, CH3. Like that a compound is there. You are asked to write the name of the compound. Parent chain is selected. Numbering of carbon atoms is done from right to left. 1, 2, 3, 4, 5. So it's having a substituent which is methyl substituent that is located at second carbon atom. So number prefix will be 2 hyphen. Name of the substituent is methyl, 2-methyl. As it is an aliphatic compound, no primary prefix will be there. Root word 1, 2, 3, 4, 5. 5 carbons will be getting root word pent. Primary suffix will be ANE. 2-methyl pentane will be the name of the compound. 2-methyl pentane, in that no secondary suffix will be there. Why? Because there is no functional group in that compound. Second example, CH3, CH, NO2, CH2, CH, Cl, CH3. In this compound also no functional groups are there, only substituents are there. NO2 one substituent and chlorine another substituent. While numbering, you should take care that sum of the locants must be lowest. So you will number from left to right. 1, 2, 3, 4, 5. 2 plus 4, 6. Right to left. 1, 2, 3, 4. 2 plus 4, 6. Then what you have to do? See the names of this substituent here. Chloro and nitro. C of chloro comes first in alphabetical order, then N of nitro. In that case, I will be giving priority to chlorine to get the lowest number. So numbering is to be done from right to left. 1, 2, 3, 4, 5. So first substituent names I have to write by using secondary prefix. 2 hyphen. Name of the substituent is chloro. That is one substituent. Second substituent is the comma 4 nitro, substituents are over, then root word, pent, primary suffix, and 2-chloro-4-nitro-pentane will be the name of that compound. See, these two substituent names are separated by comma. Locant number and substituent name are separated by hyphen. Another example, CH3, CH2, CH2, OH. No substituents are there, only functional group is there, alcohol functional group is there. Then you have to number the carbon atoms. I said to you that functional group bearing carbon atom must be the part of parent chain. It is not excluding parent chain, but it is including parent chain. So 1, 2, 3, no substituents are there, no secondary prefix will be there. It's an allopathic compound, so no primary prefix will be there. Name starts with root word, 3 carbons are there. Root word is prop. Primary suffix will be ane. Secondary suffix will be alcohol will be getting secondary suffix ol. Alcohol is attached to which carbon atom? First carbon atom. Alcohol suffix will be O. It is starting with vowel. Then last E of the primary suffix is kata. Hyphen. Look at number 1. Hyphen and ol. Propane 1-ol is the IUPAC name of the compound. Another example, CH3, CH2, CH2, COOH. Here you are tempted to go for the wrong option. Why? Because how you will be taking is, you will be taking parent chain from here, but it is to be taken from here. Why? Because functional group bearing carbon atom is a part of parent chain. So this will be the parent chain. The numbering is to be done from here 1, 2, 3, 4. No substituent is there, so no secondary prefix. It's an allopathic compound, no primary prefix. Root word, but. Primary suffix, ane. Secondary suffix, carboxylic acid capital is getting oleic acid. Then the case, as it is starting with an vowel, last E of the primary suffix is left off. Butanoic acid is the name of that compound. Then another example, CH3, CH2, CH, CH3, CHO. If you take parent chain like this, it's wrong. Why? Because functional group bearing carbon atom must be the part of parent chain. It is to be taken like this. Numbering 1, 2, 3, 4. Name starts with secondary prefix. Substituent is there, methyl. 2 hyphen methyl. 2-methyl. Root word, but. Primary suffix, and secondary suffix, aldehyde kapatti al avutundi. A is an vowel kapatti, last E of the primary suffix is taken off. So 2-methyl butanol will be the name of the compound, IUPAC name of the compound. Okay? If a compound is containing double bonds, it's an alkene. So C, CH3, CH, double bond, CH, CH3. Is there like that? So no substituents are there. So numbering 1, 2, 3, 4 or 1, 2, 3, 4. By numbering from either sides, double bonded carbon atom will be getting number 2. So don't bother about the numbering. 1, 2, 3, 4. No substituent is there, so no secondary prefix will be there, and primary prefix also won't be there as it is an allopathic compound. So its name starts with root word but. Double bond is there at second carbon atom. You can be asking me, so why can't you consider third carbon atom? Double bond at triple bond is always in found with lowest locant number. But hyphen 2 hyphen ene. But 2 ene will be the name of that compound. But 2 ene will be the name of that compound. So another compound, consider CH3, CH double bond CH, CH3, C triple bond CH. Like this a compound is there. So parent chain, single chain, no substituents are there, no problem. So numbering, where do you have to start? Double bond and triple bond are there. If a double bond and triple bond are there, just you'll be following the lowest sum rule. Double bonded carbon atom locant number plus triple bonded carbon atom locant number must be lowest. So if you see that 1, 2, 3, 4, 5, 6. So double bonded carbon, triple bonded carbon atom locant number 1, double bonded 4, 1 plus 4, 5. If you take them from left to right, 1, 2, 3, 4, 5. 2 plus 5, 7 అవుతుంది. 2 plus 4, 6 అవుతుంది. Lowest కాబట్టి right to left name చేస్తాం. So here, if you see, no substituents are there, so no secondary prefix will be there. So name starts with root word, that will be hex. If in case a double bond and triple bond are there, first double bond position is to be indicated and name should end with triple bonded carbon. Hex. Double bond is placed at fourth carbon atom, hyphen 4 ene. Name is not completed. I have to indicate even the triple bond. Triple bond means ein. It is spelled with, it is pronounced with an vowel. So last E is to be taken out. Hyphen 1 hyphen ein. Hex 4 ene 1 ein will be the name of that compound. So you'll be getting it out. Sir, if in case a compound is containing 2 or more than 2 different functional groups, how you have to number that? That's a simple doubt. If a compound is containing 2 or more than 2 different functional groups, then one of them is to be considered as principal functional group. Out of the 2 or 3 of those functional groups, one functional group is to be taken as principal functional group, then remaining all functional groups are to be treated as substituents. So how do you have to select the principal functional group? You should consider the priority principle. Priority principle. Priority of functional groups. COOH, carboxylic acid, will be highly prioritized over COOR, esters, over COO, CO, acid anhydrides rather than COCl, acid chlorides, CONH2, acid amides rather than nitriles rather than aldehydes rather than ketones rather than alcohols rather than amines rather than alkenes rather than alkynes. COR, COO, CO, COCl, CONH2. These are all called acid derivatives. That means these compounds are obtained by chemical reaction of these carboxylic acids. That means out of all the functional groups, carboxylic acid will be getting highest priority. That means if a compound is containing a carboxylic acid and aldehyde group, then that compound is to be named as carboxylic acid. And in that case, aldehyde group will be treated as substituent. Substituent, I think, is to be indicated in secondary prefix. Okay, we'll go for some examples for these compounds. CH3, CH2, CHOH, CH2, COOH. Like that a compound is there. You can see this containing two functional groups. One is alcohol group and another one is carboxylic acid group. I said to you that carboxylic acid will be highly prioritized. So alcohol group is treated as substituent. So 1, 2, 3, 4, 5. So this is substituent. First secondary prefix is written to indicate the name of the substituent. So 3 hyphen. When alcohol group is substituent, it is to be indicated by prefix. Prefix will be here. Hydroxy. 3 hydroxy. Then root word pent. Primary suffix and secondary suffix oic acid. Last E of the primary suffix is taken out. 3 hydroxy pentanoic acid will be the IUPAC name of that compound. 3 hydroxy pentanoic acid will be the IUPAC name of that compound. Second one, if you see CH3, CH2, CHNH2, CH2, CHO. A compound is there like that. It is containing two functional groups, amine group and aldehyde group. Amine group, aldehyde group, out of these two, aldehyde will be given highest priority, so that is to be treated as principal functional group. Amine is treated as substituent. 1, 2, 3, 4, 5. First name of the substituent and secondary prefix 3-amino. Amino will be prefix for amine functional group. Root word pent. Primary suffix N. Secondary suffix L. Last E is taken out as it is spelled with an vowel. 3-amino pentanol will be the IUPAC name of that compound. Another example, CH3, CH2, NH2, CO, CH2, CH3. In that also two functional groups are there. One is ketone group and another one is amine group. So ketone will be getting highest priority over amine group. So you'll be numbering it from right to left. 1, 2, 3, 4, 5, 6. Fourth carbon atom is bearing amine substituent. So I'll write it as 4-amino. Root word will be hex, as 6 carbon atoms are there. Hex. And secondary suffix will be ketone, on. Is attached at third carbon atom. 3 on. Last T is taken out. 4-amino hexane 3 on is the IUPAC name of that compound. Okay. Next one is, if it's a cyclic compound, like that is the 1, 2, 3, 4, 5, 6. No substituents are there. Name starts with primary prefix. Cyclo. Root word 6 carbon atoms are there. Hexa. Primary suffix saturated. And at first carbon atom alkyl group is there, or cyclohexanol. Like that you have to name these organic compounds. In your textbooks you are having examples. Once you can go through them, it will be clear. Stop.